Let's talk about lesson 9 then, shall we? I'd asked you to do example 1, and hopefully you saw my announcement that if you had already looked at the solutions, pretty much all the questions on example 1 that were asking you to calculate something or read something off your calculator were totally wrong. When I was writing up that solution, I obviously had different data in my calculator because they're like way totally wrong. All right, so I do apologize if that was confusing for anybody. I'm glad I caught it as early as I did. It would be terrible if I was sitting here now telling you all of that. Here's the answers, and do make sure to note that when you download the answers, if you've downloaded them earlier, make sure that you got the version that has this note on the top of it, okay? And I made all my corrections in red so you could tell which parts were corrected. Here we have a list of data that's related. We have the temperature and the quantity of beverages sold. And I just want to point out something that we're working with lines, right? And you might remember working with lines in high school or junior high. You might not have. I understand not everyone did. So you might remember the equation of a line, y equals mx plus b. We're doing that same thing. But now when we have this regression equation, we use y hat to indicate that it's a model, that it's not the actual real data. And then we're using ax plus b. So you see, we still got the b, but instead of the m, we're using an a. Why? Who knows? There's no reason for it. It's just they chose a, okay? So just understand.
Is there a simpler way to find correlation coefficients? Complex formula I found online involving sigma and a lot of division.
You're right. That's why I double checked what you were asking. We are not using those formulas. We are only using the graphing calculator.
Amazing.
Because those formulas are crazy. You can do it. It's just a lot of time subtracting and then adding and then squaring and then adding again. And it's not a good use of our time, in my opinion. So we're just getting it from the graphing calculator. When you see any of those crazy formulas in any videos or when you're checking anything online, just know we are not using those. We are 100% on the graphing calculator. Going back to this equation of a line, I just want to point out a couple things that can make things easier for you. Okay, when you were doing equations of lines back in the day, you would make a table with x, and then here would be the y, and then you'd put the ordered pair x comma y, right? So you'd have 1, 2, and then you'd have the ordered pair 1 comma 2. 3, 4, ordered pair 3, 4. That would usually be vertical. The order that we would put this in isn't a coincidence. We would put the x first and the y second because we would use this formula here to figure out the y value. You give me an x, I can figure out a y. The same is true with the order we put these in. The first thing in the column is always the x. The second thing is always the y, because the temperature is what is determining how many drinks are sold. The explanatory variable then is the x. The x always comes first and the y always comes second. The explanatory variable is always the x and the response variable is always the y. So if you're ever asked these questions here and you have a table of values, you know which is which. The explanatory is on the left, the response is on the right. Just a little hint for how you can use what you're given to your advantage and to help answer the questions. So let's talk about the correlation coefficient. I'm gonna go to the graphing calculators. So grab out your calculator so you can play along. Okay, so here I'm on my regular screen. I always like to start out with a cleared. I also want to let you know, if you're ever not sure what buttons I press, that information is down here. Unfortunately, it's just a rolling history and it just keeps adding on to itself. Let's go to Stat 1, Edit, and hopefully you have the data from example 1 in L1 and L2. Okay, so I want to look at this as a scatter plot, and remember that's zoom 9, zoom stat, and there's our data. Okay, and you may be wondering how I got that line through there. I'll show you that later. Did anyone not get a scatter plot? So what you want to do then is go to second y equals to stat plot, and you've got to turn on the scatter plots. Press enter. If the on isn't having the black box on it, you want to press enter to get the black box on it. Then down arrow and press enter on the scatter plot one if that's not already highlighted. Now, when you're doing this, make sure to double check what lists you have. X should be L1, Y should be L2. Always check this. Should default to L1 and L2, but to get the L1, remember that second one gives you L1, second 2 gives you L2, second 3, L3, etc. And now we can go back to Zoom stat. And you should have this, probably without the line through it.
I got an error, invalid dim.
Okay, here's what's happening. Go to your lists. What's happening is your lists are different sizes. It's trying to graph ordered pairs, but you see here with my list, I've got a 10 here. I've got 6 items on this list on the left, and I've only got 5 items on this list on the right. So what we need to do is add in the missing thing. But you have to be careful because remember, for our purposes, everything goes together. If you look at example 1, the 70 has to go with the 30. The 75 has to go with the 31. So read down the list and find where if I'm missing a number in the middle, I can press second delete. You see how it says INS? That means insert. You see how it inserted something there? And now I can enter the correct number that I need. So I don't have to re-enter my entire list. Okay, if you somehow put in an extra number, let's say the 6 is extra. If I press clear and press enter, the 6 doesn't go away. In order to actually erase it, I need to use this delete button, not the clear button. When you get weird things happening, there is one thing that fixes all things, and that is just to do a memory reset. Let's get that screen with the equations on it. Okay, so we're going to go to stat, over to calc, and linear regression ax plus b. Remember, we can just press the number 4. And then you want to make sure your x list is L1, your y list is L2. How I got it to store that equation so I could graph it is here. See how it says store regression equation is what that means. If you press variables, vars, right arrow over to y vars, press enter, and then enter. That will store it for you. Okay, and then press enter for calculate. You should have this screen here. So my equation is y equals 1.086 plus negative 46.17. Our equation is ax plus b, but you see b is a negative. That is when this becomes a minus. And that's why, for example 1, our equation is 1.086 minus 46.171. Did anyone not get the r squared and the r? If you're not getting those, we just have to turn on diagnostic. So now here's what the r squared and the r means. R2 literally means r squared. The r is the correlation coefficient, and that's what we did in lesson 8. That talks about strictly just how well does that data fit a line, okay? How well is that pattern of the line? And you see on this data, 0.979. That's almost perfect. But the r squared comes from squaring that value of r. That's the coefficient of determination. And what basically put, that is the explanation of the relationship between your two variables. So in this example, r squared was that as a decimal, it's 0.958. Turn that into a percentage, 97.9. So what that means is 97.9% of the sales of soda can be explained by the temperature. And that's why we call that the explanatory variable, because the temperature explains how much of the soda is sold. And of course, there's more to it. The sales, there's more to it than just the temperature, right? If there's a big party or a big group congregating nearby, they're might be more likely to buy sodas. If there's a gym next door, right? There's other things that come into play to explain the level of soda sales. And it is dependent on the sample. It will change with every sample, both r and r squared. Okay, but based on this sample here, 97.9% of the sodas sold is explained by the temperature. And that's what we use r squared for. R squared tells you how closely related those variables are to each other, okay? So the correlation coefficient, the R tells you strictly just how well they line up, and the R squared tells you how closely they're related to each other. How strong is that relationship?
Is there a possibility that you could do another example?
Yeah, I'm just making stuff up now. Okay, so here's a new set of data. I put in a sample of ice cream sales and crime. So I did my linear regression. Remember, R is the correlation coefficient. They correlate to a line at about a 0.64, which is pretty decent. So that just tells you how well it lines up as a shape of a line. This R squared tells us what percentage of the crime is to do with the ice cream. And it's ice cream because ice cream is on my horizontal axis. It's my X. And crime was my vertical axis. It was my Y. So we have explanatory variable is ice cream, X, and crime is the response variable, Y. Our calculator crunched these numbers for us. We're not doing anything by hand. My calculator says that translating this number here to a percent, 40.98% of the crime can be explained by the ice cream. Crime is explained because of the ice cream. And that is from the R squared. That's what the R squared tells us, is the relationship between whatever two variables we're graphing. And it tells you that how that relationship as a percentage. So 40.98%.
So what you're saying, like the video says, that 60% of the data is not related to the ice cream, right?
Exactly. So that's called the complement of that. If 40% is because of the ice cream, 60% is because of other things. We go back to poll 1, the soda sales and the temperature, that R squared is 0.958. We'll call it 96%. That means 96% of the sales from that vending machine is because of the temperature, which means then 4% of the sales were to do with something else.
So other reasons that the data doesn't account for.
Exactly, because we're strictly just looking at how is temperature and sales related. That's it. 96% of it is temperature, 4% is something else. If you were the shop owner, you would be keeping an eye, and especially in the summer, you'd be keeping an eye on the temperature. And if you know there's a heat wave coming, you want to make sure to have that fully stocked before then, because you know you're going to sell a lot more. As the temperature rises, your sales are going to increase. But I do want to show you just one more thing. Here's my example 1 data is still in here. I'm going to go back to the graph on this. So remember that's zoom. I already turned on the stat plot. If you didn't already, it's second y equals. It says stat plot up there. Make sure plot 1 is on and has the little dots for scatter plot. If it doesn't have that, press enter. Highlight the on by pressing enter. Arrow down. Highlight the scatter plot by pressing enter. Make sure this says L1, L2. Okay, and then we're going to go to zoom 9. Okay, so here's my data. The dots are the actual data for the sales of the vending machine. And so if we were going to write our variables down here, is our X, this is temperature, and our Y on the side here is quantity sold. Like we did with the box plot, we can use this trace button to get some information. So press trace, and you see here it says plot 1. It's looking at L1, L2. So it's plotted L1 and L2 as ordered pairs, like I mentioned in the beginning. And you see we're on the first ordered pair, 70, 30, 70 degrees, 30 drinks sold. If you use the right arrow, it goes to the next, because if you look at what example, on example 1, look at number 8 and 9, you were asked to find out what, using the equation, how many soft drinks were predicted to be sold. And there's a typo, that's supposed to be a minus in number 8. And then in number 9, you were asked to find what is the actual number of drinks sold. And here I have the actual number of drinks sold. When it was 80 degrees, I actually sold 40 drinks. I can use this trace to do my calculations as well. Right and left arrow bring me through the data in the plot, in the L1, L2. But I can get on data on the line by pressing the up arrow. And you see now here's the equation of that line. And now you see here, as I use the right and left arrow, I'm going down the equation of the line. So I can go down to 80, and you see if I'm scrolling up right and left, I'm not getting exactly 80, but I can just press in 80, and press enter. And this should match what you got for number 8. Okay, and we can use this again for number 10. So we can press 100 and press enter again because we're here on the equation of the line, and it'll calculate for us. And you should have gotten 62.4 drinks. Okay, so our model predicted 62.4. But now let's do question 11. It asks you to predict the number of drinks if it's 50 degrees out. If we press 50 and press enter, I get an error. And the reason why I get an error is because that's outside of my range of data. And my range of data is strictly what's inside that window. That's why we use StatPlot. So this I have to calculate by hand, okay? And that's also what tells you it's extrapolation because we're outside of our data range now. And the trace function, you don't have to remember that necessarily. I just wanted to show you that it is an option. For what we're gonna do in example 2, the relationship of the size of the house and the cost. How many things affect the cost of a house? Just throw them out there in the chat or just throw it out. Just say it. What's it? Location?
Neighborhood.
Mm-hmm.
Good school zones.
Mm-hmm. Size of the land you're buying?
Competition.
Is it a buyer's market? Is it a seller's market? Yep, I see people saying year it's built, square footage. If it's a fixer-upper or if it's already ready to go, no work needed on it. Or there's a whole bunch of things that come into the sale price of a house. We're just looking at one of those things. We've got this sample that is real data from that website, from, I forget, Zillow. Yeah, from Zillow in Pleasant Hill, that's just looking at the price of the house and the size of the house. And we're gonna look at and see, well, how much of that price has to do with that size. But we narrow down the number of confounding variables by looking at just Pleasant Hill, right? So then we have the same school system, we have the same location, might not be the same neighborhood, but we've narrowed down a few things that could be. I'm gonna put you in groups to work on example 2. And like I had said before, please talk to each other. Yep, go ahead.
For number 17B, wouldn't it be 23,910?
Yes, you're absolutely correct. Okay, so welcome back. Just a couple things I want to note. 17 part B, the answer is incorrect. So 17 part A, you should have 239.1. 239.1 times 100 is 23,910. So I forgot my 0 on my solutions. So sorry about that. And what that means is that you're paying an extra $24,000 for one room. One more room in a house costs roughly $24,000 more dollars.
I have a question about that problem.
Yes.
I don't really understand how to get the number from the slope. I think I did it wrong.
Okay.
I got a
So
break.
that's perfect that you asked that question because I was just going to show the calculator real quick. So we're going to go to Stat, Calc, Linear Regression. I've got my data in L1, L2. Always double check that. It saves so much time. Ignore frequency list, store. We're going to go to vars, over to y vars, function equals 1, 1, then down to calculate. Okay, so hopefully everybody got this. Okay, so r squared 0.8, or r is 0.897. That's a strong, I would even say very strong linear relationship. And this means r squared, 80.5% of the home price is to do with the size of the house. Okay, that's what that r squared means, remember. Okay, and we can look at this as the stat plot. I gotta turn this on. Press enter, and you see the default is it's already the dots. Zoom 9. There's our data. Okay, so if we want to go back and let's look at the stat plot one more time. All right, so our equation is y hat, because it's a model, it should have a hat on it. The calculator doesn't have that ability. 239.1 x plus 356,040.62. Okay, so we have, where's example 2? Okay, here's example 2. Okay, so with the equation of the line is y equals ax plus b, or you might remember mx plus b. Okay, so this is the equation of the line. The slope is always whatever variable goes in front of the x. So for us, the slope of the line is a, so that's 239.1. What the slope tells us is for every increase of 1 square foot, so that's 1x, whatever the x variable is, 1 degree of temperature, any x, whatever your x values are, the y value increases by this much. And I say make a note of this interpretation because you just fill in whatever the variables are for x and y in whichever context you're given. Our A is 239.1. We could write it as, put a 0 there for dollars. So for every 1 square foot more in house size, the price of the house increases by $239.1. Okay, so $239.10.
So would we just plug 1 into the equation?
You're not plugging 1 into the equation because that deals with all this other stuff if you plug in the 1. We're just looking at this slope. Okay, you might remember slope is rise over run. 3 over 4, go over 3, up 4, what have you. But for our purposes, the run is always going to be 1. That's why it's always the slope for every 1 square foot increase. For 1 increase in x, y increases by this, by whatever a is. So for our purposes, our slope is 239.1 over 1. Because it's a solid number, it's not a fraction. If it was a fraction, then the run might be a different number. But we're putting that 239 over the 1. And that's what's nice about the a is then you know for 1 square foot increase, 1 in x, the y is this. And this is real data. So those of you looking to buy a house, this is how much you know it increases by. And so this is actually, so an additional room costs roughly $24,000 because the average bedroom by code has to be at least 10 by 10. All right, and 10 by 10, that's 100 square feet. Okay, so for every 100 square feet increase, for every extra bedroom, roughly, you're paying $24,000 for that extra bedroom. Correlation, I would say, is very strong because it's, it's up there with a 0.9, basically, which is very strong. Here's our equation. Again, it's plus because B is positive, and the interpretation is down here. Here we go. So what is the value of R squared? R squared is 0.085, which means 80.5% of the price of a house in Pleasant Hill, this is specific to Pleasant Hill, is based on the square footage or the size of the house. That means 20% of the cost is to do with other things. And that's where you get into the shape that the house is in, the size of the lot, what schools are nearby, the neighborhood it's in, those kinds of things. And then I have some true false answers, but I just looked at the time and saw that we are quite over time. I apologize for that. The time got away from me. If you have other questions or need some help with the rest of it, I'll be sticking around for the next 20 minutes. And I do apologize for losing track of time. Thank you for those extra few minutes, folks. Great questions today, but hopefully you're feeling a little more comfortable. Hit me up if you have questions. With that, thank you very much. Sorry for going over, folks. Have a great afternoon.